All right, this is Honors Algebra 2 Pre-Calculus. We are doing 5.5 in Pre-Calc, which is multiple angle and product to sum formulae. So there will be a lot of formulae in this section. For most of them, I just need you to use, not memorize. I'll make it really, really clear which ones I need you to use frequently enough to memorize. I've highlighted them in bold red. So for instance, on this page, there's actually sort of, you can consider this 2 or you can consider it 4. Here are the formulae I need you to know. Sine of 2 theta equals 2 sine theta cosine theta comes up a lot. Additionally, cosine of 2 theta being one of these 3 options, because it is all 3 of them, either cosine squared theta minus sine squared theta, 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. Those come up a lot. Now, you could argue that if you just memorize this one, and this one, you could be okay. These two are what you get if you use sine squared theta plus cosine squared theta equals 1 to rewrite cosine squared theta minus sine squared theta. So you could logic your way through this. Like you could logic yourself to these two. So to the other two here, the 2 cosine squared minus 1 and the 1 minus 2 sine squared, by using this information, right? But again, it's helpful to know both of those. I don't have the tangent one memorized. You are certainly welcome to, but I don't. So in the next few examples and practice problems, we're going to walk through using these red formulae. All right, we're going to find the exact values of the solution to this on 0 to 2 pi, meaning you can't just lean on your calculator. So the trick here is that I need all of my sines and cosines to have the same value inside the sine and cosine. So I'm going to use the fact that I can replace this with 2 sine x cosine x. That's the trig identity that was on the last page. So I'm going to get 4 sine of x plus 2 sine x cosine x equals 0, and now I can factor out a GCF of a 2 sine x, right? So I can take out a 2 sine x as my GCF, and what I'm left with is a 2 plus cosine of x equals 0, right? So either 2 sine of x is 0, which is the same as saying the sine of x is 0. So I want when the y on the unit circle is 0, which is here and here. Or 2 plus cosine of x is 0, which is when cosine of x is a negative 2, which is never, right? Because if you picture a cosine, cosine of x is always smaller than 1 and bigger than negative 1, and negative 2 doesn't fall in that window, so that's never. So my only answers are 0 and pi, and that's it. All right, so you're going to go ahead and give the same thing a try, right? Again, the trick here is that I want to use the formula 2 sine x cosine x because I can't deal with that sine of 2x. So 2 cosine squared x minus 2 sine x cosine x. I see that there's a GCF of a 2 and a cosine, so I take out a 2 cosine of x, and what seems to be left is cosine of x minus sine of x. So 2 cosine of x is 0, cosine of x is 0. Well, that happens when the x on the unit circle is 0, which is here and here. Or cosine of x minus sine x is 0. Well, that happens when the cosine is equal to the sine. So that's when the x on the unit circle is the same as the y on the unit circle, and that only happens at the pi over 4s in quadrant 1 and quadrant 3. So my answer is going to be that x is pi over 2, 3 pi over 2, pi over 4, and 5 pi over 4. Not sure if I accidentally did theta on the last one. Nope, I did x. Cool. All right. Now, this one's a little bit trickier when we talk about E2, because remember that there were 3 choices, right? There were 3 choices. Cosine of 2 theta can either be written as cosine squared theta minus sine squared theta, or 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. Which one I pick is basically going to depend on this. So this tells me pick the one that is cosine only, because there's nothing I can do about that cosine x. So I want to pick the one that only has a cosine. So I'm going to get cosine of x plus 2 cosine squared x minus 1 is 0. 2 cosine squared x plus cosine x minus 1 is 0. So this is that secret quadratic trinomial, right? So 2u squared plus u minus 1 is 0. 2u and u. I want to net a positive 1, and I need opposite signs, so I'm pretty sure I get 2 cosine of x minus 1 and cosine of x plus 1. So either 2 cosine of x minus 1 is 0, meaning cosine of x is a 1/2, or cosine of x plus 1 is 0, meaning cosine of x is a -1. Well, cosine is a half. It's the x on the unit circle here and here. And cosine is a -1 right here. So my answers are going to be pi over 3, 5 pi over 3, and pi. All right, so we're going to go ahead and do P2, which is similar to E2. So again, we see that we have this cosine of 2x, right? Remember that there are 3 options for this. The cosine of 2 theta could be cosine squared theta minus sine squared theta. It could be 2 cosine squared theta minus 1, which is the one we used in the last example, or it could be a 1 minus a 2 sine squared theta. So to decide which one we want to use, we're going to look at this linear trig function that we can't get rid of, and since it's sine, I'm going to want to pick the one that's all sines, okay? So I'm going to get 2 plus 3 sine of x minus, in parentheses, a 1 minus 2 sine squared x, all equals 0. So when I distribute that negative to clean up, I'm going to get a 2 plus 3 sine of x, right, minus a 1 plus a 2 sine squared x equals 0. If we put this sort of in standard form with our squared term first and then our linear term and then our constant, I see that I could use u as sine x and that this would be a 2u squared plus 3u plus 1, which we can factor into 2u plus 1, u plus 1, right? And I can double check if I FOIL to check, that's correct. So I get 2 sine of x plus 1 equals 0, or sine of x plus 1 is 0. So either sine of x is a -1/2, and that would be the y on the unit circle, so that's going to happen here and here at the 2 pi over 6's that are below the x-axis, or sine of x is a -1, which is going to happen right here. So my answers are going to be 7 pi over 6, 11 pi over 6, and 3 pi over 2. Again, the way that I knew that I should choose the one that has all signs is I'm stuck with this linear sine of x, and so I choose the one that will work with that. All right, so let's go ahead and do an E3 and a P3 before we end this video. So we're going to use this information that we have to find the sine of 2 theta, the cosine 2 theta, and the tangent of 2 theta. So here's what we know. We know that the sine of theta is 3/5, right, which is a positive value, and that cosine is negative. What that means is I'm in a quadrant where sine, the y value, is positive and the x value is negative. So I am in quadrant 2, right? So I know that the sine of 2 theta is the same as 2 sine of theta cosine of theta. Well, since I'm in quadrant 2, I can draw that the opposite side is a 3, right, because sine is opposite over hypotenuse. The hypotenuse is a 5. And that means the adjacent side is a -4, because that's a Pythagorean triple, but I'm in quadrant 2. So sine of 2 theta should be 2 sine of theta, which was a 3/5, times the cosine of theta, which is a -4/5. So I seem to get a -24 over 25. I know that the cosine of 2 theta, I could use any of 3 different formulae, but I'm just going to pick cosine squared minus sine squared. I could pick any of them. You could pick any of the 3 that we've gone over, but I'm just going to pick this one. So cosine of theta squared would be a -4/5 quantity squared, minus sine is a 3/5 quantity squared. So I'm going to get that this is a 16/25 minus a 9/25, or a 7/25, right? And then for the last one, right, there is a tangent of 2 theta formula, but as I mentioned to you, I haven't bothered to remember it because, to be honest, I would just do this. We already found both of these quantities. The sine was -24 over 25. The cosine was a 7 over 25. So when I clean this up, I'm going to get a -24 over 7. And that's my answer. So there's my sine, cosine, and tangent. So let's have you try one. So now tangent is positive, right? So tangent is positive in this quadrant and this quadrant, right? In quadrant 1 and quadrant 3. But the sine is negative, right? And sine is negative in these two quadrants. So it must mean that I'm in quadrant 3. So when I draw this, I'm in quadrant 3. Here's my theta, right? My opposite side should be a -7. My adjacent's a -24, and that makes my hypotenuse a 25. So to find all of these values, I'm going to go ahead and do sine of 2 theta as 2 sine of theta cosine theta. Well, from the theta triangle that I drew, I can figure out what those values are. The sine of theta is a -7 over 25. The cosine is a -24 over 25, right? So I'm going to get that the sine of 2 theta is, and it's okay to do, you can do 24 times 7 times 2. That's just fine, right? You can get that that's a positive 336. Nobody needs you doing that by hand. And then you can go ahead and do a 25 squared if you want. It should be a 625, but just in case. So 625. So that's my sine, right? For cosine of 2 theta, again, I'm going to argue that I personally think the cosine squared theta minus sine squared is the easiest option here, but it's up to you, right? So in this situation, right, my cosine of 2 theta is going to be the cosine squared, which was the 24 over 25, and it was negative, but it's about to be squared, minus the -7 over 25 squared, right? So 24 squared, and you may or may not know this, that's fine, it should be a 576. So 576 over a 625 minus a 49 over a 625 should give me a 527 over 625. And then lastly for tangent, again, there is a formula for tangent, but I personally think it's way easier to just use sine over cosine. So it's the sine of 2 theta, which I've already found, over the cosine of 2 theta, which I've already found. So it's a 336 over 625 divided by a 527 over 625. And if I flip this to clean up, the 625s are going to cancel, right? So I flip the denominator and multiply by the reciprocal. The 625s will cancel, and I get a 336 over a 527. And that's it. All right, so that's it for this video.